Alright, let's continue. Okay, let me open the table of content. If I remember correctly, we are in chapter 5 in section homework code here. Okay, let me open that. Okay. This one, we already tried this question, the first question about variable access, and also this question about open system call and fork. Okay, and now let's take a look at this one. Write another program using fork. The chat process should print hello. The parent process should print goodbye. You should try to ensure that the chat process always print first. Can you do this without calling wait in the parent? Okay. Let me open the terminal emulator. I think it was called S3, right? And then let me open this. Okay. Okay, from this one, from this answer, maybe we can use signal. Maybe. Again, I'm not sure if we need to use select or not. Let me check. The behavior of signal varies across unique versions and has also varied historically across different versions of Linux. Avoid its use. Use sig action instead. See portability window. Okay. Portability. The only portable use of signal is to set a signal disposition to sig TFL and sig EKN. The semantic when using signal to establish a signal handler vary across system, and POSIX explicitly permits this variation. Do not use it for this purpose. POSIX solves the portability mess by specifying sig action, which provide explicit control of semantic When a signal handler is invoked, use that interface instead of signal. Okay, let's try. Let's check that out. Seek action. Examine and change a signal action. Okay. Seek action. Okay. The seek action system call is used to change the action taken by a process on receipt of a specific signal. Signum specify the signal and can be any valid signal except seek kill and seek stop. Act is non-null. The new action for signum is installed from act. If out act is non-null, the previous action is saved in out act. Seek action structure is defined as something like okay. Pointer in. Wait. Is this the function pointer? I assume it is. Okay, interesting. In some architecture, a union is involved. Do not assign to both as a handler and as a seek action. As a handler and as a do not assign to both as a handler and as a seek action. Okay. The SA restorer field is not intended for application use. POSIX does not specify a SA restorer field. Some further detail of the purpose of this field can be found in SIG-Rhythm. As a handler specify the action to be associated with signum and can be one of the following. Okay. Default action, ignore the signal, pointer to a signal handling function. This function receives the signal number as its only argument. If SA seek info is specified in SA flag, then SA seek action instead of SA handler specifies the signal handling function for signum. This function receives 3 arguments as described below. SA max, a max of signals which should be blocked, added to the signal max of the thread in which the signal handler is invoked during execution of the signal handler. In addition, the signal which triggers the handler will be blocked unless the SA notifier flag is used. SA flag specifies a set of flags which modify the behavior of the signal. It is formed by the bitwise OR of 0 or more of the following. Okay. I am still not sure about max of signal here. During execution of signal handler. This one modify the behavior of the signal. Okay. If signal is child, do not receive notification when chat process stop. Assume the receive count. Okay. This flag is meaningful only when establishing a handler for sick child. Okay. If signal is sick child, do not transform children into zombies when they terminate. Only when establishing a handler for sick child or when setting the signal disposition to sick default. To zombies when they terminate. Yes, sick action instead of wait. Let's see. I can access this. Okay. Then avoid. I've understood that one VIT is used to wait for a chat process finish and then collect the sick child and the exit status of the child, etc. When we have a signal handler for sick child, we do some more things related to clean up of child or other stuff to the programmer, okay? And then to wait PIT so that the chat will not go zombie and then return. Let me copy this in the chat in case anyone want to see this too. Now, do we need to have both 1 and 2 in our program when we do a fork or exec and the chat returns? If we have both, the sick child is obtained. If we have both, the sick child is obtained first, so the signal handler is called first, and thus its wait PIT is called successfully, and not the wait PIT in the parent process code as follows. Okay, it is the correct value of the chat PIT. Wait a minute, print the MP. Is that something like that? Let me check. I don't think that exists. Nothing. Okay, interesting. Say action, okay. My signal handler for child. Okay, say action. It is a struct, right? Do something written. And then wait for it to finish. In that case, you just call with PIT when you're ready to synchronize. The only thing SigChat is used for is asynchronous notification of chat termination. For example, if you got an interactive or long-running diamond application that's spawning various children process and needs to know when they finish. Trying to make sure that process finish first before parent process without await or await PIT. Okay. And needs to know when they finish. However, SigChat is really bad or active for this purpose too. Since if you're using library code that creates chat process, you might get the event for the library still terminating and interfere with its handling of them. Signal handlers are inherently process global and deal with global state, which is usually a bad thing. Is this trademark? Okay. Here are two better approaches for when you have chat process that will be terminating asynchronously. Approach 1. Select or pull event base. Make sure you have a pipe to or from each chat process you create. It can be either their STD in, STD out, or STDR, the standard stream, or just an extra dummy file descriptor. Okay. When the chat process terminates, its end of the pipe will be closed, and your main event loop will detect the activity on that file descriptor. From the fact that it closed, you recognize that the chat process finish, right? That the chat process finish and call with PIT to read the zombie. Okay. Approach 2. Thread base. For each chat process you create, also create a thread that will immediately call with PIT on the chat process PIT. And with PIT written successfully, use your favorite thread synchronization primitive to let the rest of the program know that the chat terminate or simply take care of everything you need to do in this waiter thread before it terminates. Both of these approaches are modular and library friendly. They avoid interfering with any other parts of your code or library code which might be making use of chat process. When the chat process terminates its end of the pipe, because its file descriptor that is connected to the pipe end, and there are no other process having file descriptor connected to that pipe end, then the other end of the file of the pipe will be signaled as cause end of file. I believe that would explain more precisely what happened. Two process having file descriptor to a pipe open and suffer from a race condition when doing with PIT. With the W no hang option or flag. Okay. This is the chat process close to pipe, but the chat process had barely not exited yet. So the wait PIT call wouldn't read the chat process. And artificially limited no unit in which function I'm allowed to use, I end up going with Qt's recommendation method of having a single global pipe that my SIG handler write a single byte to, and my pull code then reads a single byte from mentioned in here. Okay. The pipe to serve is the pipe to serve trick is common. Recommended by Qt. Interesting. Okay, let me put this in the chat. It's Linux specific, right? The signal FT. Is limited to async signal save function, so allowed to use, right? But forbidden to use fprintf or malloc inside a signal handler. Signal. Okay. Let me also copy this in the chat. we add this in here. So for Mac OS, we still need this. And it is a Linux specific system call, the Signal FT. Back to save. Let me check. With PIT with 6 action. And avoid where is it? Okay. Using with me IT. I mean, action to wait for, what is it? Child process. Wait for chat process. Parent and for chat process. And is that how can I know? Action, okay. Clean up function. What is PIT? God, let me was this. Okay. Examine or change a signal action. Combination of input or output. Okay, let's check the return value. Return 0 on success, on error -1. Okay. None and then info. But then again, what is the struct action? This one. Okay. Handler. Function pointer in. Specify the action to be associated with signal and can be one of the following. The default action to ignore the signal. A pointer to a signal handling function. This function receives a signal number as its only argument. A signal number as its only argument. Number as its only argument. Let me check. Signal handler. Where is the child in this case, in this snippet? Signal, okay. One. Okay. For exact. That make me wonder. Okay, let me try. Signal handler. Maybe I should create the function void. Okay. Handler in, maybe something like this. Signum. Okay. Let me check. Void handler. Right. I need to also give the message. Maybe calling this in here, something like this, and of course change this to parent. Okay, and then parent handler. Okay. Maybe something like that. But then, do we need to clean up after the chat process finish? To leave the zombie, right? Someone tried to approach someone and suffer from this condition. The chat process closed the pipe, but the chat process had barely not exited yet. Single global pipe that message chat handler write a single byte to and my pull code then reads a single byte from. You could have zombie process. A usual way of handling this is the pipe to self tree. Serialization time. Pipe equal pipe. And maybe we need to use select. Synchronous input-output multiplexing. Okay. I mean, what is it called? The limitation of select is that it have low limit for the file descriptor. Yeah, if I understand correctly. With this size, right? Select a program to monitor multiple file descriptor, waiting until one or more of the file descriptor become ready for some class of input-output is considered ready if it is possible to perform a corresponding input-output operation without blocking. Let me try. So I also use, what is it called? Okay, so we use the signal first before we fork. So we will get interrupted by a signal. Passage using a passive waiting. Okay. On Linux. Signal. Is there an example? A signal missing type do not transfer children into zombies when they terminate. Only when establishing a handler for sick child if the SA no child wait flag is set when establishing a handler for sick child. POSIX leave it unspecified whether a sick child signal is generated when a child process terminates. On Linux, a sick child signal is generated in this case. On some other implementation, it is not. Okay, we have undefined behavior again. Do not transform. Okay. This is one of the, okay. Do not receive notification when chat process stop. Okay, that is receiving one of these signal or resume. Let me check. Say chat null info. Info.shandler equal check-in. Signal being ignore. if sender set default, set ping default. Wait a minute. So the info will be stored in this one. Is that it? So we don't need to, what is it called? Give the value there. Okay, let me check again. Restrict egg. Oh, okay, this one. Signum and then egg. Okay. And then this one. Old egg. Oh. And what is egg? Egg is non-null. The new action for signal. Signum is installed from egg. If egg is non-null, the new action for signal. Signum is installed from egg. If old egg is not null, the previous action is saved in old egg. Okay. So we are saving the previous action in the info here. And we provide null. Something like this. Okay. The action to be associated with signum. Okay. Modify the behavior of the signal. Oh, since Linux 2.6. Okay. New handler. Sig anti-set. What? New handler set. I mean, can we really wait using sig action? To specify my sig as a signal handler and then set the signal handler for sig set without an info. Let me put this in the chat too. If anyone wants to take a look. Using pipe. Things to keep it in mind. Use signal instead of wait. Instead of passive width. Interesting. P1 and P2, that's the semaphore. I'm still not sure what semaphore is. Currently, it's with an initial value of 1 and also 3 variable. Okay. Random concurrently on computer with a single CPU. Is it possible for P1 and P2 to get into a deadlock? How I look at it is that as soon as they start running, they put wait until something signals them. Since nothing else is running, then aren't they busy in deadlock? They to run until to wait just before that statement gets executed. At this point, semaphore S2 and S1 have a count of 1 and S3 a count of 0. Now P1 execute until wait. Oh, we are still using wait. Okay. Instead of passing wait. Okay. A signal to notify the program to begin a certain action instead of having it continually loop to check to see if condition attained. Sets a timer and when timer expired. Oh. A program based on run select and have a pipe pair dedicated to supporting signal. The read N is written by signal handle. Let a single byte contain the number of the signal and have the select include the read N of the pipe in the read FD set. Then when a signal occurs, a single byte is written to the pipe. This will up the select, the code in the select loop, then reads the pipe, knows which signal occurred and can then handle it in a more graceful manner. Maybe this is something similar to this one, pipe to self trick. At initialize time, you set up a pipe called pipe, and you keep both read and write file descriptor of that pipe in some global data. Okay. Signal handler would just write onto the right and FD some byte have a single 0 byte. I had to put this okay. Using pipe to self trick. This one using signal and select. Your signal handler will just right, and your even loop around pull, or the outer select would track by read. By reading point when the read and file descriptor has some data. Okay. Data set of function usable inside a signal handler is limited to async signal save function. So you are allowed to use write but forbidden to use fprint f or malloc inside a signal handler. Pull, Okay. Wait for some event on a file descriptor. Oh. Wait for some event on a file descriptor. Similar text to select, it waits for one of a set of file descriptor to become ready to perform input-output. The Linux specific epoll, it is specific to Linux apparently. The epoll may perform a similar task but offer features beyond those found in pull. The set of file descriptor to be monitored is specified in the fdisk argument. It is an array of structure of the following form. Okay. Which one should I use? For a single pull call, simply set the fd field to its piecewise complement. Yeah, I am not sure if sig action will wait the chat process to finish. It looks like, what is it called? Doing some action after the process finish, but I'm not sure if it will wait until the process finish. That's why some people combine this with wait PID, I guess, or the wait system call to make sure the chat process finish and then doing something after that. Maybe I'm still not sure. Yeah, maybe. Okay. Should we try this first? Time out. Okay. Let me check the select then. NFTs. Okay. Okay. Read NFTs. Okay. Write accept time out. Yeah, we are using struct temp file. To monitor multiple file descriptor, waiting until one or more of the file descriptor become ready. For some class of input-output operation, a file descriptor is considered ready if it is possible to perform a corresponding input-output operation. That blocking. A command of select rt-set of file descriptor. Declare with the type ft-set. Okay, ft-set is a structure type that can represent a set of file descriptor. According to POSIX, the maximum number of file descriptor in an ft-set structure is the value of the macro ft-set size. Okay. It's allowed the caller to wait for 3 classes of event on the specified set of file descriptor. Each of the ft-set argument may be specified as null if no file descriptor are to be watched for the corresponding class of event. Upon return, each of the file descriptor set is modified in place to indicate which file descriptor are currently ready. Then out. That terminated. Okay. So if I understand correctly, we wait for the, what is it called? The chat process to finish in the select, right? And then when we got the signal, child, we, what is it called? We do something like we, what is it called? We make we add indicator that the child signals the child process already finish, right? We set indicators for the child process already finish in this case, in this condition. So we do something when the chat process finish. Maybe something like that. So we are replacing the wait with select, if I understand correctly. And then, well, we also add indicator, I guess, with the signal system call. I mean, similar to this condition, I think. Right? That is conditional. Maybe I'm still guessing. Okay, I guess that's it for now. Yeah, maybe I will try this out finally on the next session. I want to check, right, which one is doing the waiting. And currently my hypothesis is that in this snippet of code, in this piece of code, the one doing the waiting is on the select system call, I assume, and then the signal in here is to, what is it called, to change the indicator that the chat process already finished, something like that. Okay, so we have, what is it called? I think we have two options. Let me put this in here. Currently have option using select with using select for, what is it called, as replacement of wait or wait PIT. Second one using pull. Maybe I should put this in here. As replacement of wait or wait PIT, using select or using pull. And then using signal or and then possibly using signal or sig action to add an indicator that chat process already finished? Question mark. Okay, on the next session we might try this out. Okay, I think that's it for now. Thank you for watching and see you next time. Bye bye.